Hi, I'm Jenny, and I'm going to be going over the patterns of association. This 8th grade math standard is usually taught in statistics and probability class and stems from 5th and 6th grade math. In 5th grade, students represent the real world and math problems by graphing and interpreting coordinates in the first quadrant on a graph. In 6th grade, they're using all 4 quadrants. Students also understand a rational number as a point on a number line previous to the current standard. It is followed by a deeper understanding of linear association and scatter plots, as well as interpreting categorical and quantitative data. The goal is to investigate patterns of association in bivariate data and analyze scatter plots. The math standard for today is to construct and interpret scatter plots for bivariate measurement data to investigate patterns of association between two quantities. Describe patterns such as clustering, outliers, positive or negative association, linear association, and nonlinear association. Now let's break it down word by word. A scatter plot is a graph created by plotting points from given or observed data and shows a relationship between two sets of data. The graphs are what scatter plots should look like. Bivariate measurement data consists of a pair of numerical observations that are linked. For example, this chart shows the temperature outside and ice cream sales. We can see that the data is linked because as the temperature increases, we see an increase in ice cream sales. Association refers to the relationship between two variables. There is a positive association when the values of one variable tend to increase as the values of another increase as well. There is a negative association when the values of one variable tend to decrease as the other increases. Linear association occurs when the data tends to have a linear trend. This occurs in both positive and negative association. Nonlinear association occurs when the data doesn't have a trend in a straight line. For example, this one has a trend in a curve. And then there is no association when there isn't a relationship between the variables, and as you can see, the scatter plot is very scattered. When deciding whether the association is negative or positive, you can also determine the strength of it. When data points are closer to the line of best fit, there is a strong association, and when they're more spaced out further from the line, the association is weak. When they're somewhere between the two, it's a moderate association. Association is the presence of a relationship, not to be confused with correlation, which is used for only linear relations. Distinct groups of points may occur on scatter plots sometimes. These are called clusters. An outlier is a data point that differs significantly from other observations. This generally occurs when there is some error or inconsistency in the data. Outliers can have a drastic effect on the strength of association in data. This plot shows a few outliers and how the positive linear association occurs. And then this plot shows how the association changes when outliers are non-existent. An important part of scatter plots is the plot description. You should always use the form, direction, strength, and outliers to describe the data. I go over that here in this slide. Let's practice. Pause the video and describe the scatter plot using the plot description guidelines we just discussed. The solution needs to include the form, direction, strength, and outliers. That is, this scatter plot shows a strong, negative, linear association between age of drivers and number of accidents. There don't appear to be any outliers in the data. Now here's a more challenging task. Pause the video again to answer these questions. To make the plot, you will use a graphing program like Excel and the data given. The scatter plot should look like this. Now we can see there are a couple points further away from the rest. So yes, there appear to be two outliers, being the African and Asian elephants. To create a new scatter plot, simply remove the data from the elephants. Notice that the plot shrinks and is more readable. Using the same plot, we can see that there is a slight positive linear association. Thank you for following along. I hope this video proved to be helpful.